Alright, here we're going to learn about similar figures. So mostly we're going to focus on similar triangles this unit, but the proportional relationship between similar figures applies to similar triangles, so we're starting with similar figures, and then we'll narrow our view to similar triangles. So similar figures have the same shape, but not necessarily the same size. Two polygons are similar if and only if corresponding angles are congruent and corresponding sides are proportional. So the angles need to be the same. The sides are not going to be the same length, but they're going to be proportional. And what that really means is that they're going to be multiplied by the same scale factor, going from 6 up to 8, 12 to 16, 15 to 20, 9 to 12. It's going to be multiplied by that same number to get us those new lengths. So corresponding angles are going to be congruent. So F corresponds with K, so those are congruent angles. M corresponds with H, so those are congruent. And then when we think about our sides, we can set up a proportion. That's what it means to be proportional. We can set up two ratios comparing any four sides, really. FG, not any four sides, but corresponding four sides. FG compares to GH the same way KL compares to LM. Those are corresponding. That one corresponds with that one. That one corresponds with that. So in the proportion, they should line up across from each other. So KL over LM. So we can just compare side lengths. We can also think about what numbers those would actually be. ML, that side, compares to HG as 12 over 16. So that ratio is really 3 to 4. We're just simplifying that fraction. The similarity statement is written like this, with that tilde in between, saying that FGHJ is similar to KLMN, same way as congruent triangles. These correspond. So side FG corresponds with side KL. Alright, so we can use proportions. And we can use scale factors. A lot of the times, it's going to be more intuitive to use a scale factor to find a missing length. Sometimes it's necessary to use proportions, but a scale factor is really handy, especially when you just see what it's being multiplied by. If something's just doubling, you don't have to set up a full proportion. You could just use that scale factor of 2 to figure out the new length. So the skill of solving a proportion involves cross-multiplying. We have a fraction on this side, a fraction on that side. We're going to cross-multiply, which means we multiply the numerator of one side times the denominator of the other. And then the denominator of that same side by the numerator of the other side. So 37.5 times x becomes 37.5x, and then 5 times 30 is 150. To solve that, we'll just divide by the 37.5 and get that x is 4. When we have an expression here, this is one of the times where we really need to set up a proportion. When we have an expression, it means we're going to cross-multiply and distribute this number into every term on top of that fraction. So we're going to do 6 times 2x. 6 times x plus 2. And that means we have to distribute into both those terms. It's multiplied by the entire quantity on top. Same thing on the other side. 2 times 5x minus 2. We have to distribute the 2. So we get 6x plus 12 equals 10x minus 4. We're going to combine like terms, get 4x equals 16, so x is 4 again. One more time with a proportion. This just involves actually setting it up. So QR is 15, NK is 12, and LM is 10. What's the length of SP? Alright, so we're comparing corresponding sides. 12 compares to 10, as x compares to 15. Cross multiply, we get 180 equals 10x, so x is 18. So the next thing we're going to talk about is a scale factor, and it's possible you already saw it here. Going from 10 to 15, that's being multiplied by 1.5. That is the scale factor. You're timesing by 1.5. The same scale factor will apply to this, times by 1.5. 12 times 1.5 is also 18. So there's just two different ways to accomplish the same thing. We could set up the proportion, or you can think about what scale factor, what multiplier took us from this number to that number, the same multiplier will take us from here to there. That is what a scale factor is. It is a multiplier for all the lengths of similar triangles. So scale factor can be used to represent the ratio between two corresponding sidelines and two sidelines within the same triangle. The order matters. If I say the scale factor from FGHJ to KLMN, from this one to this one, that is going to be a number that's smaller than 1, going from 8 down to 6. We want to think about what we're multiplying by. 8 times something to give us 6. We would solve that, divide by that 8. It's 6 over 8 or 3 over 4. So our scale factor here would be 3/4. The scale factor is whatever we multiply by to get to the new figure. So it's going from this one to that one, that direction. That means we're multiplying by 3/4. It's got to be a number smaller than 1. On the second one, it's the exact same thing, but it's going the opposite direction. Now we're talking about going from this to this. So going from 15 to 20. 15 times something to give us 20. X there would be 20 over 15. We're dividing by 15. Or 4 over 3. This is always going to be the case. These fractions are reciprocals of each other. If you multiply this by 3/4 to get here, you're going to multiply this by 4/3 to get to the bigger shape. So that's going between our two figures. Here it says triangles. It could be triangles, but it doesn't have to be triangles. Here we can see it also works with the quadrilateral. This one is talking about the scale factor from HG to FG. From HG to FG, going from 16 to 8. We want to think about what we must have multiplied by there. Scale factor has to be 1/2. 16 times 1/2 would give you 8. All right, I'm going to go over a couple of these problems. It's cut off, but it says Lance the alien is 5 feet tall, and his shadow is 8 feet long. At the same time of day, the tree's shadow is 32 feet long, creating a pair of similar triangles. Actually, we don't really even need this sentence. We're going to assume that they're standing perfectly upright, which means that is forming a right angle. And if it's at the same time of the day, the ray of sunlight coming in here creates an angle here. That same angle is created by this ray of sunlight. So this angle and this angle correspond with this angle and this angle. And if you have two shared angles between two triangles, we know that we have similar triangles here. So now we're trying to find the height of the triangle. I'm going to do this in both ways. I'm going to find a proportion that works for this and a scale factor. So the proportion is the height compared to the shadow, which is 5 over 8. Then height compared to the shadow is x over 32. So we cross multiply and get 8x equals 160. So x is 20. That's using a proportion. We could also use a scale factor thinking about the shadow. That's multiplied by 4, going from 8 up to 32. Same scale factor is going to be applied there. 5 times 4 is going to give us 20. So you can see, in this example, I feel like it's more intuitive to just use a scale factor. I see clearly that that's being multiplied by 4, so the same thing's going to happen there. That's also multiplied by 4. There's other examples where proportion is more intuitive, especially when you have an expression. We'll get to examples later, but if you see an expression here, then it might be easier to use a proportion rather than just using the scale factor. All right, last one I'm going to do with you. ABCD is similar to EFGD. ABCD is similar to EFGD. And DG, the length of DG, is twice the length of EF. So this is twice the length of EF, or I could just write that as 2y. We're trying to find the perimeter of ABCD. All right, so in addition to each side being proportional, the entire perimeter is proportional. So if I can figure out the perimeter of this figure, and I know the scale factor, I can also multiply the entire perimeter times that scale factor to figure out the perimeter of the big shape. All right, first, let's figure out that scale factor. Going from 9, the full length there, down to 6. 9 times something to equal 6. that is 2/3. So that is my scale factor going from the big shape down to the small shape. So I'm going to apply that for these two. Times by 2/3, times by 2/3. This would give me that x is 5, y is 3.3 repeating. And if this is 2y, that means that's 6.6 repeating. So right now we have some decimals, but it's kind of convenient because when you add these two together, that gives us exactly 10. Plus 5 plus 6, that's 21. So the perimeter of this shape is 21. If I apply that scale factor to go from the big shape to the small shape is 2/3, I would use the reciprocal of that fraction flipped upside down, of 3/2. So multiplying there, that would give us 31.5 as the perimeter of the big trapezoid. Alright, that is similar figures. Hope this helps. Try some of that you try on your own. If you need help, ask for help.